Okay, so we should all be on this page here. At the top, it says triangle similarity. And on the board, I have written out similarity tests, okay? I'm not talking about like a test that you guys are going to take and I grade and all that. I'm talking about tests or like rules that we can use in order to show that two triangles would be similar to each other. We've done this before with congruent triangles. We were able to use different congruence tests in order to say that this triangle was congruent to this triangle because of like side, side, side. Okay. We had 5 different congruence tests that we could use. Let's just review those from our time when we were going over congruent triangles. So just across the top here, I'm going to write congruent triangles. I'm going to abbreviate a lot of that too. And I just said one of them, side, side, side. Do you guys remember the other 4? Side, angle, side. What's another one? Angle, side, angle. That's everyone's favorite, right? And the last one. Angle, angle, side. Good. Those are the 5 that we talked about last semester when we were trying to show that 2 triangles were congruent to each other. If we had markings that followed one of these 5 patterns, we were able to say that the triangles were congruent. Now we're going to switch it a little bit into how do we show that triangles are similar. And so we're still going to be using a couple of these tests that we had for congruence. We're not going to be able to use all 5 though. There's only 3 tests that we have for similar triangles. 2 of them come from that list up above. The third one is one that we were not able to use when we talked about congruent triangles, but we could use for similar triangles. So the 2 from up above that we can continue to use when we're talking about similar triangles is the side, side, side test and the side angle side test. When we use those tests, though, we do have to check one piece of information. We've talked a lot so far in this unit about when you're dealing with similar triangles, a dilation has occurred. The triangle got bigger or smaller proportionally in all directions. So when I'm working with sides, I have to make sure that they are proportional. So I'm just going to add on a little note here that says sides must be proportional. That means that at some point when we're working with triangles and their side measurements given to us, we're going to have to still use this idea of these ratios, these proportions that we've been spending some time on the last couple of days, still setting those up and still making sure that they're true for the triangle that we're working with. Now, the third test, and this is the one that I said we were not able to use, so it's not in that list up above for congruent triangles, but it does work for similar triangles, is angle, angle. So let's talk about why it's angle, angle, and it's not 3 angles or just 1 angle. If we are looking at triangles, and you know in triangle number 1, you have an angle that's 30 degrees and 60 degrees. And you're looking at triangle number 2, and you know that there's an angle that's 30 degrees and 60 degrees. What do you guys know about the third angles on both triangles? They're going to be the same. Why are the third angles guaranteed to be the same on a triangle? If you know 2. The other 2 would have to be the same. If I have 30, 60, what does that leave me with for the third angle? 90. Because they have to do what? They have to add up to 180 all the time. That's never going to change. So if I know 2 out of the 3, that third one is technically locked in. It can't be changed from one triangle to the next because then you're not dealing with a triangle anymore. You have a different shape. The sides either don't connect or it's maybe got a gap or something, and then it's causing you to have to start thinking about working with a quadrilateral or something other than a triangle. So on these similarity tests, you only need 2 angles in order to use angle. We don't have to have all 3 because the third one should be a guaranteed fit. So down below, we have some pictures of similar triangles or potential similar triangles. And this kind of looks and resembles what you did with congruent triangles. You've got 2 pairs. You're trying to see, does it fit into one of our 3 tests? Now, we only have 3 this time. So side, 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 and angle. So if it doesn't fit into those 3, it's an automatic no. If it does fit into those 3 and we're dealing with the ones with sides, we can't just say yes, side, side, side. You will have to check the sides before you can say yes and like guarantee that it's similar. So let's do these together. We're just going to go through them one at a time. Starting with this first one. What's marked in the picture? 2 angles. And do we know that they're the same? Yeah, don't they have the same markings? You have an open circle, you got a little star. So we know, I don't need to know how much they are, but I just know those are the same. So does this satisfy one of our 3 tests? Which one? Angle. So you can say yes, angle. Okay, looking at B. Is there a test that you think we could be using potentially? Maybe side, angle, side. I agree, because it looks like there's an angle marked. That's that open circle. Those match. The sides, we just have to check, though. Are they proportional? Does anyone have an idea, though? Because I don't have like anything to go off of. Like there's no similarity statement. There's no, not all the sides are marked with like numbers, or not all the angles are marked. Does anyone have a thought on how do I know what side length goes with what from the 2 triangles? Like how do I know what number to put 8 with? Yeah, Mason. The longer side? Is that what you said? Because isn't 8 the bigger out of these 2 numbers, everybody? 8's bigger than 7. So down here, is it 14.4 bigger than 12.6? So the bigger side should have to go together, and the smaller side should have to go together too. It's not necessarily anything that we've got like in written like explanation up there that those things have to go together, but we should be able to make those connections and start to say, all right, these longer sides should probably be matching on a triangle and these shorter sides to match. Now, to check if they're proportional, I'm going to set up those sides that we said should go together. So I'm going to put 8 with the 14.4. And I'm going to put an equal sign with a question mark above it because I'm checking to see if they're proportional. And I'm going to do 7 over 12.6 on the other side. Now, there's a couple ways that you could check if it's proportional. This looks like a normal proportion. You guys could cross multiply and make sure that you get the same amount both times. The other option, and this is the one that I actually want you guys to do with me because it's going to show up a little bit later, is you could divide these numbers. Take 8 divided by 14.4 and take 7 divided by 12.6. If we get the same answer both times, it's going to be proportional. So can someone tell me what is 8 divided by 14.4? 0.5 repeating. And how about 7 divided by 12.6? Same thing? That's what I want to see happen. When you're looking at the decimals, though, all of it has to match. So I said this to first hour. If you got 0.5555555 the first time, and then the second time you divide, you get 0.5556, those are not identical. Because that one's ending before, it doesn't show that it's repeating. You'd have to say, no, they're not proportional. The decimals have to be identical to each other in order for you to say yes. But these ones work because they both come out to be 0.5 repeating. So now we should be able to come back up here, circle our yes, and use the test side, angle, side. You have to do this, though. You have to check the sides because they might throw in a random number. They might have said 12.5 instead, and that would change this entire thing, and those sides would not truly be proportional anymore, which means something happened with that, with the getting it bigger or smaller. It wasn't a true dilation. One of the sides kind of went off and got a little bit weird. All right, let's look at letter C. What do you guys think about this one? Did any of you like initially think no? Because that happens sometimes. When you are given that information, maybe you thought, no, those don't match. Okay? Does anything match though? The 51s are good. Now we know the other two don't match, but could we find this angle? How? It's going to be the 67 because we're going to add these two things together, subtract it from 180, and that's going to come out to be 67 degrees. Now, do we have enough to say that they're congruent or similar? Yeah, because what test can we use now? Angle, angle. How much do you guys know this angle to be then? Good, should be 62. Shouldn't have to think too hard about that. So even if they don't have like the angles, all of them matching right away, check to see what's that third one, because it might possibly still match like we just found, okay? Any questions on those first three? Are we doing okay? All right, let's go to the next one. It's obnoxious. They're emptying the dumpsters. Okay, let's take a look at this one. Do you guys see the two triangles that you're trying to show are similar? Can you name them for me? Good, ABC and AEF. When Brady said those two names, what letter was shared between the two? A. So isn't A going to be the same? So I should be able to mark A immediately. I'm going to go ahead and just put an arc up here. A is going to be the same on both triangles because that's where they overlap. All right, I don't have like any numbers on this picture. What are these arrows telling you? Those are parallel. So can we use those parallel lines to help us find something? What can we use them for? These are parallel. Okay, you're thinking about like angle pairs? So if I connected either E to A or F to A, doesn't matter which side I go on. Like I could do this, or I could have that go here. What are those lines known as when they cut through those parallel lines? A transversal. When transversals are happening and they're cutting through those parallel lines, angle pairs are going to start to show up. But let's talk about what angle pair we have here. If I'm looking at just what I have highlighted and I'm looking along that yellow transversal that I highlighted there, I would probably be trying to connect that where the corner of B is and the corner of E is. You guys agree with me? What kind of angle pair is that? Corresponding. Do you guys remember what makes angles corresponding? They have to be on the same side of your transversal, and one has to be interior and the other has to be exterior. Is that happening here? B would be considered exterior, E would be considered interior in relation to those parallel lines. They're on the same side of my yellow transversal though. Is the same thing happening at C and F? It is. So if I really wanted to, I could mark those up as well. Do I need to though? No, because I marked A and then I marked one of those pairs. I should be able to just say, yes, angle, angle. Did I need to mark A? Or could I have just used my corresponding angles? That would be enough too. If I don't want to use that A, I don't have to. Those have two pairs of those corresponding angles. That would also be enough to just say angle, angle for my test. So you'll see something like that on your homework today. And they probably won't always label the triangles either. They might just give you the picture, no letters even. That doesn't change the problem though. Think back to what we just talked about here when you see something like that in the future. All right, what do you guys think about letter E? Can we use a test on this one? No? What are they giving us? An angle and a side. Do we have a test that says AS? No. So this is just a no. There's nothing we can do with that one. Okay, how about F? What are we maybe trying to use? We're trying to use side, 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 but I have to check, are the sides proportional to each other? So if I'm looking at the little triangle, 9 is the biggest side. What should 9 go with on the other side? Good, 10.8. So I'm going to put 9 over 10.8. What should the 8 go with? 9.6. So then the 5 should go with the 6 on the bottom there. This is why when we did that test earlier on letter B with side angle side, I had you guys divide your fractions, because if you're trying to cross multiply in here, it's possible, but it gets kind of messy because you got to do it here, here, and you have to check this one and cross multiply there as well, and make sure that you get the same product every time that you do that. I think it's a little bit faster to just divide, check to make sure that my decimals match perfectly, and then I should be able to say yes. Do these all come out to be the same? What's the answer for all of them? Okay. So that should be enough for us to circle yes up above, and we would write side, side, side. On a side angle side one, you only have 2 sides to check. You do have to check all 3 on this one here, because again, they might throw in like one number that throws the whole thing off. If you don't check all of them, you might miss the one that maybe causes the issue by just like luck, by grabbing the right sides maybe. But you have to check them all. They will do that every once in a while. They'll try to sneak something in there to check to make sure you're paying attention. So make sure you check all those sides. All right, do we have any questions on these top 6? Okay, so if you guys look down below, this is really no different. They added one extra piece. What are they wanting us to also write now? They also want a similarity statement. You guys have also done this with congruent triangles. It works the same way. So first of all, are these triangles similar? Yes or no? Yep, what test are we using? Angle for this one. And then we just need to write out a statement. So someone give me a name for the big triangle. FGE. And that would line up with what letters over here? Good, MHK. Again, make sure you're putting them in the right order. Matching pieces still need to go together. That's still important here. I will be checking for that. If you get a letter mixed up, you're going to miss a point, like on your test when you're asked for those similarity statements. So make sure that you're being extra careful. How about for B? How do you know it's a yes? So you're already thinking of the proportion. Like you thought 3 to the 6, 5 to 10, 4 to 8. You could have also gone the other way. Okay, you could go 10 over 5, 8 over 4, 6 over 3 if you wanted to go that way. It doesn't really matter how you set up these proportions. So if we did that either this way, all of these break down to a half, a half, a half. If you flip them, it would just be 2 over 1 or 2 instead. But you still get the same answer all the time. So you should still be able to say yes, side, side, side. And what's a statement you guys could write out? Good. A, B, C, D, E, F. Any questions on that?